Okay, so everything we talked about involves composition with a reference type object that's not a collection of some kind. So in Java, an array is also a reference type, right? So if a class has a field that's an array, you need to consider whether or not you should be using aggregation or composition. If the array has elements that are primitive types, so if you have an array of int, for example, then the situation is much easier to deal with than if the array has elements of reference type. Right, so we'll talk about what happens when you have a collection of reference types in the next lecture. Okay, so I want to implement a class that represents a combination lock, right? So this is just a simple combination lock with some dials, and the dials have numbers between 0 and 9 on them, right? And so it'd be like an inexpensive combination lock that you would use to lock up a kid's bike, for example. So we're going to have a lock that has a combination that has at least 3 digits, but it can have more. So it has a variable, potentially non-constant number of digits. And furthermore, the lock is in either one of two states. It's either locked or unlocked. So when I go to implement this class, I have to pick some fields. Right? One of the fields I need has to be able to store at least 3 digits, so I'm going to use an array of int. The other field needs to represent the state of the lock, so I'm going to use a Boolean value for the state of the lock. Right? So the field will be true if the lock is locked. It'll be false if it's unlocked. Okay, so our class combination lock. Every lock has an array that holds the combination of the lock. It has a field that says whether or not the lock is locked. Okay, now remember when you have a field that's an array, like combination, right? All that means is that you have a field that can store a reference to an array. It does not mean you have an array yet. So the constructor must make the array and assign it to combination. Right. Our no argument constructor makes a lock that is locked and has the combination 999. So the no argument constructor makes an array of size 3, sets the elements of the array to 9999, and sets is locked to true. If a constructor receives a combination from the caller, right, and we're using composition, we have to make sure that we copy that array from the caller. Right? Failing to at least make a copy of the combination is a potential privacy leak, right? So our constructor that takes in the combination that's provided by the caller, the first thing it must do is it must make a copy of that array. The easiest way to make a copy of an array in Java is to use the method arrays copy of. Copy of takes an array, and it takes in the desired length of the resulting copied array. Right? So this can be shorter than or longer than the array that you're copying. Right? If this is shorter than that array, then the resulting array contains just the first many values from that array. If this value is longer than the length of this array, then the returned array contains all of the values in that array, plus a bunch of zeros so that you get that length. If you want to make an exact copy of an array, you pass in the array and the length of the array. Right? So combo copy is an exact copy of combination in this case. Right? We're going to look at the length of the copied array. So now we're going to validate the copy. So I'm going to check, is there at least 3 digits in the copy? If there isn't, we're going to throw an exception. You should also loop over the values of the copied array to make sure that they're between 0 and 9. But I don't have room on the slide to do that, so I haven't done that here. Only after the copy has been validated can you assign the copied array to this combination, and now we can set is locked to true. If you have a copy constructor, then you have to make a copy of the other locks combination. Right? Now, the easiest way to do this is just to use constructor chaining. So the copy constructor copies the state of that lock, right? So it copies its combination, and it copies the locked state of that of the other lock. So the easiest way to copy the combination is to just call the other constructor using chaining, right? So that calls this constructor here. This constructor here makes a copy of the combination and sets this combination to the copy, right? Finally, we have to copy the state of the locked state of the other lock. So we set this is locked to other is locked, right? There's no new or anything here, right? Because is locked is a primitive type, right? Okay, so when we talk about composition, or when people learn about composition for the first time, the tendency is that they copy everything, even when they don't need to, right? And so you don't always have to make a defensive copy, right? You only need to make a defensive copy when there is the danger of a privacy leak. So for example, if we want to write a method that takes in an array, and that array contains a combination, and we want to use that combination to unlock our lock, right? Then there's no reason to make a copy of the incoming array, right? We're not going to assign that array to our lock, right? All we're doing is we're checking, is our combination equal to the array that was passed in, right? So there's no point to make a defensive copy in this case, right? So our unlock method takes in an array that's a combination. We want to check, is that combination equal to this combination, right? The easiest way to do that is to use arrays.equals. So if this combination is equal to that combination, then unlock the lock, right? Otherwise, do nothing to the state of the lock, right? So again, there's no defensive copy here because there's no danger of a privacy leak. Right. And so that ends the lecture on composition part 1. In the next lecture, we're going to look at what happens when you have a composition and one of your fields is a collection of some kind.
Moving right along with the lecture. So we were talking about the relationship, the structural relationship between classes, right? So we were talking about aggregation, composition, and association. So we saw that in composition, you're making defensive copies everywhere. Well, not everywhere. You're making defensive copies when there's the danger of a privacy leak. Right? And so we saw what happened when you had a field of a class that's of reference type, but we haven't seen what happens when you have a field that's actually a collection, and the elements of the collection are not primitive. So in other words, they're reference types as well. Right? And so this happens quite a lot because you often it's the case where you implement a class and that class has a collection of some kind. Right? So for example, a university has a collection of faculties. Every faculty has a collection of schools and departments. Right? If you're a receipt, a store receipt has a collection of purchased items. Right? The contact list on your phone has some sort of collection of contacts. Right? Ignore the from the notes part. So it's very common in these introductory programming courses, you end up with a class like student or employee or something like that. Right? So you might model a student as having a collection of GPAs and having a collection of courses that they're currently taking. One of the examples we'll be looking at today is this thing called a polygonal model. So a polygonal model has some sort of collection of triangles, more generally polygons, but triangles are normally easier to work with. All right, so what does a collection actually hold? And this is true for an array as well. Right? So if a collection is a collection of elements. Right? And so it turns out in Java, the collection does not actually hold the elements. Right? Like everything else in Java, a collection holds references to elements. Right? So if you make a list of dates, right, and then you make 3 dates, right? Now remember D1, D2, and D3, right? These aren't actually dates, right? They're references to dates. So when you add D1, D2, and D3 to the list, right, you're adding references to the list, right? So in other words, the list is not storing the dates themselves, right? The date objects are in memory somewhere. The list simply holds references to those elements. Right? So for example, right? There's our list dates, right, is the object at address 200. So we come down to the list object at address 200, right? Our dates D1, D2, and D3, these are references to objects at address 500, 600, and 700, right? They're not shown on the slide because they don't fit, right? But inside the list, you also see 3 references, right? References to the 3 dates, but not the date objects themselves. This is true in Python as well, right? So in Python, everything's references. So in Python, when you have a list, it's a list of references. All right, so having just told you that, let's look at the following example. Right, so points is a list of points. Right, I'm going to make a point P. Its coordinates will be 0 and 0. Right, I'm going to add P to that list there. Right, and then I'm going to change the x coordinate of P, right, to 10. So if you print out P, you should get 10 and 0. Right, so it's one of these two here. Right. Now, what happens when you print out the first point in points? Right? Well, you also get 10 and 0. Right? Because that point there and that point there, right, those are actually both references to the same point object. Right? They're both references to the point whose coordinates are now 10 and 0. Right? So again, the list doesn't actually hold the point. Right? It holds a reference to a point. Oh, similarly, the list doesn't make a copy of this point either. Right? So it doesn't copy P and add it to the list. Right? It simply stores a reference to P. Okay, so when you are talking about, or when you're drawing the UML diagram for a class that has a collection or collections of some kind, most of the time you don't actually show the collection itself. Right? So here we've got student. Right? So student's got a string as an ID. Probably a student number of some kind, right? Student has a collection of GPAs, right? So notice what the UML diagram shows. It shows that student is an aggregation of some GPAs, right? It doesn't show the collection that's storing the GPA, right? So in other words, it doesn't show that student is a something of a list of GPAs, right? Similarly, it doesn't show that student is a list of courses. Right? It says that it shows that student is just an aggregation of 0 or more courses. That's what the star means. Star means 0 or more. And so normally you don't show the collection itself, although you can. Right? It depends on what information you're trying to show in your UML or trying to communicate in your diagram. But normally you show the element type and not the collection type in the diagram. Okay, so we're going to start with this polygonal model class. Right? Polygonal model is just a collection of triangles. Right? So it's a collection of 0 or more triangles. Each triangle is an aggregation of 3 point 3 objects. So point 3 is just the analog to point 2, except it's 3-dimensional points. Right? And so that's an aggregation, and that's aggregation. Right? Again, notice that the list or the whatever collection I'm using to hold the triangles isn't shown on the diagram. Okay, so we're going to start with aggregation. Oh, here's an example of several polygonal models. Right? So if you play any 3-dimensional video game or watch any 3-dimensional animated movie, everything is eventually turned into everything is eventually turned into triangles. Right? So objects that appear smooth, like the apple and the ball, they're actually just a discrete collection of triangles. Right? Some of the triangles are very big. Right? So the ground is made up of a relatively small number of large triangles. Right? Oops, sorry. The fact that everything looks smooth when you shade it is purely an illusion of the way that the shading is done. If you take the fourth year computer graphics course, SYS 454, you'll learn how all this is done. It's surprisingly not that complicated, at least the basic stuff. Okay, so here's our class, polygonal. Oh, sorry. There's our class polygonal model. Right? It's going to be an aggregation of triangles. So I'm going to store my triangles in a list. Right? So it's a list of triangles called tri. Here's my no argument constructor. Right? What does the constructor do? It always initializes your fields. So we make a new list for tri. We'll have a copy constructor later on, but for now, this is our only constructor. The clear method removes all the triangles from the model, so it simply asks the list to clear itself. Right? So when you clear a list, the size of the list becomes 0. Size returns the number of triangles in the list, right? So it just asks the list for the number of triangles, or for its size. All right, so here's the problem. So when you're using a collection as a field of a class, right, you now need to decide ownership issues, right? So number one, does your class X, does it own its collection, or does it share its collection, right? So in other words, are we going to make an aggregation of a list, or are we going to do a composition of a list? Right? If X owns its collection, does it also own the objects that are held in the collection? Right? So in other words, if you have a composition of a list, right, do you also have a composition of the elements in the list? Right? So those are the questions you need to ask. Here, in this example, we do not. Right? So we're using, we have an aggregation of the elements in the collection. Okay, so if X shares its collection with other instances, then you don't have to bother. You don't have to bother with composition at all. Right? In other words, you don't have to make copies anywhere. Right? So, for example, in the copy constructor, right, you don't have to make a copy of the list. You just say your list is equal to the other object's list, and away you go. Right? And what does that mean? It means X's collection is just an alias for another collection. Right? So, in other words, right, in our polygonal model copy constructor, we just write this trie equals other trie. Right? And what does that mean? It means that list is the same list as that list. Right? They're aliases. These two names are aliases for the same list. Right? If you're doing it, if you're implementing your model, your object this way, or your class this way, sorry, then if you have a method that returns the list of triangles, you can just return a reference to your list, right? Because you're willing to share your internal list. So in a picture, this is what would happen, right? So if I have a polygonal model P1, and I make a copy of it using the copy constructor, right, and assign that model to P2, right? There's your first model P1, there's your second model P2, right? Inside each model, there's a list of triangles, right? And these are the same lists, right? So they refer to the same list object, which is up here, right? When you look inside this list object, you see that there's two triangles in it, right? And that's the triangle there and there, right? So you have two polygonal model objects, right? 1, 2. You have only one list that's shared between them, and you only have two triangles that are shared between the two models. Right? So neither model owns either the list or the triangles that are in the list. Okay, so a little example here. If you got a model P1, it has 100 triangles in it. Right? I run the copy constructor that I just showed you to make P2. Right? And now we clear P2. Right? So P2 takes its list, removes all the triangles from the list. Right? And then we print out the size of P2. Right? So the size of P2 had better be 0, because we just cleared it. Right? But what happens to the other model? Right? So what's its size now? Well, it's also 0. Right? Why? Because when you clear P2's list, right, P2's list is the same list that P1 has. So P1's list also clears, and the size of P1 now becomes 0. Right? This isn't a flaw in the way that this is implemented, right? It's merely a consequence of the choice that we've made, right? We've decided we want to share the internal list, and so this is one of the consequences that you live with. Yes?
What does alias mean again?
Alias is just another name for something, right? That's exactly what alias means, right? Yeah, so let me go back to that one copy. All right. So this trie is a name of a reference for a list, and other trie is also a name for a reference of the same list. That's it. Okay, so if you decide that maybe this isn't what you want to do, right? So maybe when I clear P2's triangles, maybe I shouldn't clear P1's too, right? So maybe I really want to own the collection, right? Or each model should own its own collection, right? So if X owns its collection, but it does not own the objects in the collection, right? Then your copy constructor can perform what's called a shallow copy of the collection, right? And so when you make what's called a shallow copy of a collection, right, you make a new collection, right? So you create a new collection, but you don't copy all of the elements that are in the collection, right? So you make a new list, but you don't go into the list and then copy every element from the list and put the copies into the new list. Instead, all you do is you just copy over the references from the other list into the new list. Right? And so your lists end up at containing references that are aliases for the references in the other collection. Right? So in other words, both lists contain the same references. Right? Okay, so it's still aggregation if you're drawing the UML diagram and you're drawing the element type here. Right? Because the model doesn't own its triangles. Right? Back here, we're making a shallow copy. Right? Both lists contain references to the same triangles, so neither model owns the triangles. Right? So it's still an aggregation of triangles. If you were to draw the list instead, now it would be a solid diamond, right? So you'd have a composition of a list of triangles. Right? That list would be an aggregation of triangles, right? And each triangle would still be an aggregation of points. Right? So it's still aggregation of triangles, but it's a composition of a list now. Now that it's a composition of a list, now you have to make a copy of the list when you need to. Right? So how do you make a shallow copy? So let's make a shallow copy of date objects, for example. Right? This applies to whatever list you're copying. Right? So I have a list of dates called dates. Right? I want to make a shallow copy. Right? So what does shallow copy mean? It means make a new list. Okay, so I make a new list. Right? And now it means take all the references from the copied list and put them into the new list. Right? So iterate over the original list. Right? And take each element reference and put it into the new list. Right? And so you can write a loop and do this manually if you really want to. Right? Don't do it this way. Just call the copy constructor. Right? So the copy constructor for lists and sets makes a shallow copy of the list or set. Right? So when I use the copy constructor to copy the list dates, the resulting list is already a shallow copy. Right? So you get a new list, but the elements in the list are the same, are references to the same objects as the original list. Right? The same is true in map. Right? So if you have a map and you copy another map, you end up with a shallow copy of the other map. All right, so if I want to change the way that we implement the polygonal model so that it now owns its list, I have to change the copy constructor, among other things, right? So now I have to use composition, so I have to copy the other list of triangles, right? I can make a shallow copy, so I can just use the copy constructor, and now I can assign the copy to this dot try. Right? If you were implementing get triangles, is that what I called it? I don't remember what I called it. Right? You would also have to make a copy of your list before you returned it to the caller. Right? So all the rules for composition now apply. All right, so our picture now changes slightly. Right? So with our second version of the copy constructor, if I copy P1, right, I still end up with two polygonal models. Right? But the lists inside each polygonal model, they are now different list objects. Right? So I now have the first list here, I have the second list here. Right? But if you look at what's inside the list, right, the elements that are in both lists, well, they're just references to these two triangles again. Right? So I have two polygonal models, two lists, right? And I still only have two triangles. Right? So neither model owns the triangles. Right? They both own their lists, but they don't own their triangles. All right, same example as before. Right? P1 has 100 triangles in it. I run the second copy constructor now to make P2. Right? And I clear P2. Right? And then we print the size of P2. Right? So after clearing P2, P2 had better be 0. Right? So that's fine. What is the size of P1 now? Well, P1's list is not the same list as P2 anymore. Right? Contains the same elements, but it's a different list. So P1 size remains 100. Right? And so that's the difference here. Right? So now when you modify the list of one object, the list of the other object does not change. All right, so what happens if you look inside both lists? Right? So P1, make a copy of it using the copy constructor. Right? I'm going to get the first triangle from P1. I'm going to get the first triangle from P2. I'm now going to ask, are they the same triangle? Right? Not equal, right? Are they the same triangle object? Right? The answer is yes, they are the same triangle object. Right? You just go back to the picture, right? That's the first triangle in the second list. That's the first triangle in the first list. Are they the same triangle? Yes, they're both the same triangle, right? Okay, so finally, you can ask the question what happens if the object owns its collection and it wants to own the elements in the collection, right? And now this is what you have to make what's called a deep copy, right? So a deep copy of a collection means make a new collection, right? And now copy every element that's in the collection and put the copy into the new collection, right? So the references in your copied collection are references to brand new objects, right? The new objects are equal to the objects in the other collection, but they are distinct objects. Right? So now you have a composition of triangles. Right? You also have a composition of a list, right? But it's a composition of triangles now because the model owns its triangles. Right? Notice, however, that the triangle, right, each triangle is still an aggregation of 3 points. It's still an aggregation of 3 points. Okay, so how do you perform a deep copy on a list? So there is no convenient way to make a deep copy of a collection. And in general, you cannot always make a deep copy of a collection. So to make the deep copy, you make a new list, or a new set, or a new map, right? Iterate over the list that you want to copy, right? For each element in the list that you're copying, make a new copy of that object, right? So for dates, we can do that. Right? But it could be the case that you have a class and there's no way to actually copy objects of that class. Right? So in other words, it has no copy constructor and there's no obvious way that you can make an exact copy of an object. Right? So in Java, there's no guarantee that you can actually copy an object. Right? The language doesn't impose that restriction on programmers. Right? So you could run into a situation where it's either very difficult to copy an object or impossible to actually know if you're copying an object unless you can see the source code. So you can't always make a deep copy, at least not easily. Right? But if you can, then you're making new objects, right, that you're adding to your new list. Okay, so how do you do this for our polygonal model class? So we're going to modify the constructor. The copy constructor yet again. Right? I now need to make a deep copy. So for the list of triangles, I make a new list. Right? I loop over the other list. Right? For each element in the other list, I make a copy of that element, and I add a reference to the copy to our new list. Okay, so the picture now looks like this. Right? So copy constructor, so there's two polygonal model objects. Right? Each polygonal model has its own list. Right? So there's the first object's list, and there's the second model's list. Right? Now the elements in both lists are also distinct. Right? So the first list has references to the two triangles here. Right? And the second list has references to the two triangles on the next slide. Right? And so now we've got two models, two lists, and 4 triangles. Right? So in other words, each model has its own triangles. Right? Okay, same example as before. Right? I'm going to use our third copy constructor to make a copy of P1, and P1 has 100 triangles in it. Right? I'm going to clear the model that we just made, and I'm going to print out the sizes of the two models. Right? So what do you get? You get 0 and 100. Right? P1 has its own list, so when you clear P2's list, P1 does not change. Right? Again, same example as before. I'm going to get the first triangle from both models. I'm going to ask, are they the same triangle? And I'm going to ask, are they equal? Right? So are they the same triangle? No, they're no longer the same triangle. Right? So that's false. Are they equal, though? Yes, they are equal. Right? So both models have their own triangles. The triangles are equal for the time being. right? But now if you change a triangle in one of the lists, the corresponding triangle in the other list does not change, right? So you've actually made a complete independent copy of your model, right? And notice what you had to do that, right? You had to copy both the collection, right, and the items in the collection in order to make a truly independent model, right? Oh, okay. Any questions on the contents today of that lecture? All right. So we've covered the four basic relationships between, structural relationships between classes, right? So we talked about dependency, association, aggregation, and composition, right? There's one more, and it's the, one of the important ones in object-oriented programming. Okay, so the next relationship between classes is called inheritance. But before we get to inheritance, we're going to take a short but related detour to talk about interfaces. All right, so remember what an interface is. We've seen comparable, right? So the comparable interface says that if a class implements the interface, it has to provide a compare-to method, right? And it also says that the compare-to method must behave a certain way. So an interface is just a specification of the methods that an implementing class must provide. Right? Normally in an interface, it's just a bunch of methods and that's it. Right? There's no definitions for the methods. There's only the method declaration and the contract or the specification of the method. More recent versions of, well, not more recent versions of that. I guess more recent versions of Java, we'll go with that. They allow you to have what are called static methods inside of an interface, and they also allow you to implement methods in an interface, and they're called default methods. Right? For now, we're not going to worry about these two, but we will come back to these later in the course. Right? Okay, now remember, interfaces are actually types in Java. Right? So list, set, and map, they're all types, right? And they're all interfaces. Right? So you can make a variable whose type is list, right? So that's an interface. Right? What can you store in that variable? Well, I can store an array list in that variable. Why? Because array list implements the list interface. Right? I can store a Java util linked list in the variable t. Right? Why? Because linked list implements the list interface. If you make your own list class called myList, and you say that it implements the list interface, you can store a myList object in the variable t. Right? And so this is the, I guess this is the first, well, this is the first time I've explained that you can have types, like ArrayList, that are substitutable for some other type, like list. Right? And this is also an indication that in Java, objects have more than one type. Right? So this ArrayList object over here, right? The fact that I can store that in a list variable here, right? That sort of implies that this object here, its type is both ArrayList and list, right? So it has more than one type, right? Linked list, its type is linked list, but it's also list, right? And myList, its type is myList, but it's also list in this case, right? So objects in Java can be substitutable for other types, right? And similarly, objects in Java have more than one type. Okay, so recall that a class that implements an interface must implement all the methods that are in the interface, right? So if you say that your class implements comparable, then you have to provide compare-to, right? What about other interfaces? So the iterator interface is the interface that specifies or defines objects that know how to iterate over a collection of elements or a sequence of values. Right. So using an iterator object, it turns out it's the only safe way to iterate over a list or set or a map and remove stuff from the list or set or map. Right? We don't actually talk about that in the course, but if you want to, you can look this up in the notebooks, and it shows you how to use an iterator to remove stuff from a list or from a collection as you're iterating over the collection. Whenever you write a for each loop, the compiler is producing an iterator object for you. Right? It hides all of the iterator creation from you, but what's happening under the hood is that an iterator object is being created, and the iterator object is iterating over the collection in your for each loop. The interface for iterator has two methods. There's two more methods that aren't relevant for our discussion right now. Right? So there's a method called hasNext, and there's a method called next. Notice that iterator is a generic type. Right? So you have to specify the type of the element of the collection that you're iterating over. Right? So if you have a list of a list of integer, then the iterator for that list is an iterator over integer objects. Right? hasNext returns true if the iterator has more objects to visit in the collection. Right? And next returns the next element in the collection. Right? If hasNext is false and you call next, you get an exception, right? Because there's no more elements left to iterate over. Okay, so there's a second related interface called iterable. Right? So any object whose class implements iterable gets to be a target for a for each loop. Right? So in other words, you can write a for each loop as long as your object implements iterable. Right? So list implements the iterable interface for the element type E. Right? Set implements the iterable interface for the element type E. Right? Now you know that you can write a for each loop with an array, but it turns out arrays don't actually implement iterable. The language only pretends that it does. Right? So in other words, the compiler has to do something special when you write a for each loop over an array. Right? It doesn't actually work the same way as iterating over a list or set. Okay, iterable only has one method. Well, only one method that we care about, right? Iterable says it returns an iterator. So in other words, if your class implements the iterable interface, you know that you can get an iterator over that class, over objects of that type. Right? So list implements iterable, so you can get an iterator over a list. Okay, so in Python, you know that in Python all for loops look like that. Right? They're all for I in something. Right? If you want a counting style loop in Python, you know that you use the range class. Right? So if you write in range 0 to 10, you get a loop that counts from 0 up to 9. Right? Of course, you can skip values and you can start, you don't have to start at 0, et cetera, et cetera, et cetera. Right? Now this is kind of nice, right? This is a lot nicer than writing the Java style or the C style counting type loop. Right, for int I equals 0, I is less than something, I plus plus. Right? It's a lot easier to write that. Right? It's also, in Python, the only way to write a for loop is like that. Right? So there's only one for loop in Python. In Java, you have to deal with the fact that there's 2. Right? There's actually 3 if you count the iterator, but anyway. So if you want to do the same thing in Java, you can, but you shouldn't. Right? But you can. Right? So in Java, you can do the same thing. You just have to make a range class. Right? That corresponds to Python's range class. Right? You have to use new because you need to make a range object, but otherwise it looks almost exactly the same. Right? And so you can do this. You just have to implement range. You make range. Oops, sorry. You make range implement the iterable interface, and then you define an iterator for your range class. So that's what we're going to do right now. All right. So here's our range class. Right? Now, what does a range represent? Well, it represents an integer set of values starting from here, going up to but not including that. Right? So a range has a min and a max. Right? It might have a step size too. If you want to implement that, we're not going to do that. Right? So we have a min and a max. Right? Or a start and a stop. Right? We want range to be the target of a for each loop, so we have to implement iterable. Right? And range is supposed to produce integers, right? 0, 1, 2, 3, 4, 5. So it's iterable integer, right? The iterator is going to produce integer values. Okay, so we have our first constructor, right? It takes in only a stopping value. So this is the one that's going to count from 0 up to, but not including stop. Right? And I'm just going to chain this to the second constructor. So the second constructor takes in 2 values, start and stop. Right? So we're going to start at start, we're going to go to stop. Start is always less than stop. less than or equal to, right? So we have to check, is stop less than start, right? If it is, we're going to throw an exception. If you want to count down, you have to do something else, but we're not counting down in this class, right? It's easy to change though, right? Otherwise, we're going to set this start and this stop, this start and stop, right? That's it. It's pretty straightforward, right? We just have to do one more thing. We have to provide an iterator method, right? Because that's what the iterable interface says, right? That interface says you must provide iterator. So here's iterator, right? We're providing an iterator that produces a number, an integer value. So it's an iterator over integers, right? And now we have a problem, right? Because there is no class, iterator class that does this for us. So we have to make our own. Right? So the class that we're going to make is called range iterator. It's an iterator over a range, right? That's why it's called range iterator. All right, so where are we going to put this class? We're going to put it inside the range class. Right? So this is the first time you've seen a class inside of a class, right? So we have a private class called range iterator, right? Range iterator is going to implement the iterator interface, right? So in other words, it's going to provide has, next, and next. Right? So this particular class is called a nested inner class, right? Or just inner class in Java, right? Notice that it's private, right? And so a top-level class can't be private, right? Top-level classes can be public. Can they be? Top-level classes can be public, right? Or package private. You can't make a private top-level class, right? Because no other class can see it, so it doesn't make any sense, right? You can make a private inner class, though, right? And what that means is that only the range class can actually see the range iterator class, right? So only range objects are able to make range iterator objects, right? And that kind of makes sense, right? Because no one else needs to make a range iterator object, right? You need a range to iterate over. So it doesn't make sense for anybody else to independently make a range iterator object. Right? Whenever you see a private inner class, what that's trying to tell you is that this class here is something that's implementation specific to the outer class here. Right? So in this case, it's trying to say that this range iterator class is only useful to the range class. Right? And therefore, no one else needs to know about it. Right? So we make it private so that no one else knows about it. Right? They can still use it, right? Because they still get back, iterator still returns an iterator. Right? So whatever object is returned by this method, right, people know that they can call has, next, and next because those are the methods that belong to iterator. Right? But they never actually know that it's a range iterator object that's coming back. Right? They just know that they're getting some iterator. Okay, so a nested class. There's a lot of terminology here, and unfortunately the terminology is specific to Java, right? So other object-oriented programming languages don't use the same terminology. Okay? So a nested class is a class that's defined inside of another class. Okay, so range iterator is defined inside range, therefore it's a nested class. Right? Nested classes usually only exist to serve the class that they are defined in, usually but not always. If you create a nested class and you realize, hey, this would actually be useful to somebody else, then you should probably make it a top-level class. Right? However, the standard library actually breaks this rule, and it defines this class called entry for maps. And remember, in a map, an entry is just the row of the map. Right? So there's a counterexample right there. Iterators are normally defined as nested classes, right? Because you can't have an iterator without an object that you're iterating over. Right? So in other words, having a list iterator makes no sense if you don't have a list. Right? Having a set iterator makes no sense if you don't have a set, and having a range iterator doesn't make any sense if you don't have a range. Right? So what's a nested inner class? Right? So a nested inner class is a class that's nested and not static. Right? It's a bit of an odd definition because I'm telling you what it's not. Right? So if the word static does not appear here, then this thing is an inner class. Right? And I'll tell you what static nested class is in a later lecture. Okay, so if you have an inner class, like we do in this case, then objects of the inner class have a reference to the enclosing class object. Right, so what does that mean? It means every range iterator object has a reference to the range that it's iterating over, which makes sense, right? The range iterator needs to know how big the range is in order for it to go from the start to stop. Right, so it needs a reference to the range that it's iterating over. And you get that if you create an inner class. Right? Inner class objects can access the fields of the outer object. So range iterator has access to the private fields of range. Right? So in other words, range iterator can see start and stop. The naming for it is weird, but it can see the fields. Oops, sorry. Right, and it also makes sense in this case, right? So a range iterator, if it's iterating over a range, it needs to know what is the starting value of the range. It needs to know what is the stopping value of the range. Right? And so it makes sense that it needs to be able to see the fields of the enclosing class. Okay, so what does a range iterator object actually do? Right. All right, so when you make a new range iterator object, right, remember what it's supposed to do? It's supposed to start at the beginning of the range, and it's supposed to be able to look at every element in the range. Right? So when you make a new range iterator object, right, it's supposed to start counting from the starting value of its range. Right? So if you make a range iterator object that starts at 0 and goes to 10, well, up to but not including 10, right, the starting value of the range iterator should be 0. Right? Whenever you take the object and ask for the next value, right, it returns the next value in the range. So it's called next, but it actually returns the current value in the range. Right? And then it goes to the next element in the collection, or in this case, in the sequence. Right? So the first time you call next for a range iterator object that starts at 0, you get 0. Right? The next time you call next, you get 1. The next time you call next, you get 2, and so on, and so on, and so on. Right? Whenever you call hasNext on the range iterator object, right, it returns true if there's still some more values to look at. Right? Otherwise, it returns false. Right? So again, the range iterator object that goes from 0 up to but not including 10, when you get to 9, hasNext returns false. Right? So this is not terribly complicated to implement. Right? So here's our range iterator class now. Right? So the range iterator class needs to know what is the current value. Okay? So it needs a field called value. Right? So that's just the current value that next is going to return. Right? So the no argument constructor, right, it's going to start at the beginning of the range. Right? So this value is just equal to the starting value of the range. Now notice the weird syntax that you have to use. Right? So to get to the value field inside range iterator, you would write this dot value. Right? To get to the start field that's in the range class, you have to write range dot this dot start. Right? The syntax is bizarre, but that's just the way it is. Right? That's the way the designers of the language created the language for as. Right? So range dot this dot start is the starting value of its range object. All right. So how does hasNext work? Right. So remember, hasNext returns false when you get to the when the value becomes the last number in the range. Right. So if the value is less than the stopping value, right, you're going to return true. Right. So in other words, when value becomes, so if you have a range object that starts at 0, stops at 10, right, then when value gets to 9, right, you can call hasNext, you can call next one more time, because it'll return the 9 and then add 1 to the value. Right. Finally, next. Right, so next is supposed to return the value and then add 1 to the value. Right? So we're going to return this dot value and add 1 to this dot value. Right? So we return the result, which is this value. Right? Add 1 to it. Right? Now, next throws an exception if it's already at the end of the range. right? So how do you know if you're at the end of the range? Well, just ask has next, right? So if has next returns false, throw an exception, right? And that's the way next behaves, right? And that's it. There's your range iterator class. Right? And so now you can write the following, right? You can now write your Python style for each loop, right? That counts from 0 up to 10, right? If you actually run this code, you will in fact get 0 through 9, right? It's not too much work to change your range. Where is range? Right? It's not too much work to change this class, right? So that it counts in steps of something other than 1, or it counts downwards from some larger value to some smaller value. Right? So it's not too much work to change this class. You also have to make some small changes to range iterator, right? But again, it's not very difficult to do. Okay, so that was a rather complicated example for our first interface, for our second interface, right? Anybody have any questions about what just happened, about what we just talked about? All right. What happens if you want to make your own interface, right? So it turns out interfaces are enormously useful in Java, and that's why there's so many of them in the standard library. So it's natural that you might want to make your own interface, right? And so to make an interface, it's very easy, right? You declare what looks like a class, except you call the class an interface, right? Everything in the interface is public, right? You don't have a choice about that, right? So even if you don't put an access modifier on it, the compiler is going to make it public anyway. If you use any modifier that's not public or blank, the compiler will not compile your code. Right? So everything's public in an interface. All right, so if I want to make an interface called printable, right? And so printable is going to be an interface for objects that you can print to the console. This is not particularly useful. This is just a very simple example, right? You just make an interface, right? Give it a name, right? And now you just list the methods that you want your interface to have. Right? So now you just add whatever methods you want. Each method ends in a semicolon. Right? So here's my method print. Right? Returns nothing. Print simply prints the object to standard output. Right? And that's it. There's our printable interface. Right? Any class that implements printable, someone can just call print and the object gets printed to the console. Okay, so for example, we can take one of our classes like point2, right? And now we can have it implement the printable interface, right? So a class can implement more than one interface, right? Point2 currently implements comparable, right? Now we want to implement printable, so you just put comma and then the next interface that you want to implement, right? So in Java, a class can implement an arbitrary number of interfaces, right? There is no built-in, there's no predefined limit. Well, there's no predefined unreasonable limit anyway. What does print look like? Well, you're just going to print the thing to the console, right? So it's just system.out.println, right? What thing are you printing? Well, you're printing this object, right? How do you print the object? Well, you get its string representation and print the string, right? That's it, right? So basically all we've done is instead of having to write system.out.println p for point2, right? Now point2 can just write p.print, right? So this isn't that most useful interface in the world.